Good morning, students. I'm your Nagini ma'am. Today I'm going to discuss about important numericals in solutions lesson. Students, second PUC topic, colligative properties. Okay, now. So in the last video, I discussed the two colligative properties. One is relative lowering of vapor pressure, and second one is elevation of boiling point. Okay, now. So, two colligative properties I discussed, students. In this section, I'm going to discuss about the third and fourth colligative properties. One is depression of freezing point, another fourth one is osmotic pressure, students. So that numericals I am going to discuss. Okay, just to save the time, already I wrote this problem, students. See here. 1 gram of non-electrolyte solute dissolved in 50 grams of benzene lower the freezing point of benzene by 0.40 Kelvin. Find the molar mass of the solute. Clear the students question. So what asked students here, we have to find the molar mass of the solute. We know that colligative properties mainly used to calculate the used to find the molar mass of the solute. Correct, students? So here in this problem, so what is the clue, students? What is the trick, students? Freezing point. Here freezing point word is there in the problem. Okay, now. So what formula we should use? This one. Freezing point word is there in the problem. So then you have to use the which formula, students? Freezing point. See here. Freezing point. Important formula. Important formula. Freezing point. This is freezing point problem, students. Depression of freezing point, that is decrease in the freezing point. So here what is the in the problem freezing point, what is there? You have to use formula, students. Which formula you have to use? Freezing point, delta Tf is equal to Kf into W1 by M1 into 1000 by W2, students. Understood, Amma? So delta Tf is the depression of freezing point and Kf is the freezing point constant, and W1 or the molar depression constant. W1 is equal to weight of the solute, M1 is the weight of the molar mass of the solute, and W2 is the weight of the solvent, students. Clear this one? So what is delta Tf, students? Here delta Tf is equal to depression of freezing point. Depression of freezing point. Okay, depression of freezing point. Kf is equal to what, students? Freezing point constant. Freezing point constant. Okay, and W1 is equal to weight of the solute. Weight of the solute, and M1 is equal to molar mass of the solute. Molar mass of the solute. Okay, and W2 is what, students? Weight of the solvent. Okay, weight of the solvent. Understood, Amma? So here W1, M1, this both are belongs to solute, students. Clear this one? This is solute, this is solvent weight. Clear this one? Solvent weight. Okay, so this formula you have to use. Freezing point word is there. This is the colligative property problem, students. So this is a third colligative property. You have to use this formula. So write that formula, students. Solution, delta Tf is equal to Kf into W1 by M1 into 1000 by W2. Correct? So delta Tf is equal to, here what we have to find, students? Molar mass of the solute we should find. Correct? So delta Tf value what given, students? Lower the freezing point of benzene by 0.40 Kelvin. How much given? Delta Tf value 0.40 Kelvin given. And Kf value. Kf is what, students? It is a freezing point constant already given in the bracket. In the question only given. See here, what is the Kf value? 5.12 Kelvin given. Kf value, correct? And next, W1 is weight of the solute, students. What is the weight of the solute given? 1 gram given. Okay, 1 gram. And M1 is equal to molar mass of the solute. We have to find it, correct? And next, W2 is weight of the solvent. What is the weight of the solvent? 50 grams. So weight of the solvent is equal to 50 grams. Understood, students? Here what given? Delta TF value given. Lower the freezing point of the benzene. How much? 0.40 Kelvin. And next KF is 5.12 Kelvin given. Okay, now KF value given. It is the molar depression constant. Correct? It is a molar or freezing point constant. Next W1 is equal to weight of the solute 1 gram. It is dissolved in the how much weight of the solvent? 50 grams. So that's the W2 is equal to 50. M1 is we have to find molar mass. Okay, substitute here. We have to find M1. So from this formula we can write M1 is equal to what we can write, students? M1 is equal to Kf into W1 into 1000 by what we can write? Delta TF into, we have to find M1 number. So Kf into W1 into 1000 by delta TF into W2. Then Kf value. What is the Kf value, students? 5.12 into W1 value 1 and next into 1000 divided by delta TF value 0.40. Correct? 0.40 into W2. What is W2, students? How much given W2? 50 grams given. Correct? Now you calculate, students, how to find it, this value. See here. So in the numerator 5.12 is there. 5.12 into 1000. 5.12 into 5.12 into 1000. Okay. And next divided by 0.40. 0. Sorry, students, once again 5.12 into 1000 into 1000, next divided by 0.40 into 50 number. We have to divide this one, 0.40 again divided by 50. Clear? So divided by 50. Understood, Amma? How much answer you got, students? 256 answer. So answer is 256 gram per mole. Clear? So this is the answer. Understood, students? So here in the problem freezing point is there. That is a third colligative property. You have to use this formula. Understanding? Here delta TF value directly given. But in some questions, students, delta TF value directly they won't give. Okay, the freezing point of the pure solvent and freezing point of the solution they will give, Nana. So how to find the delta TF? What is the formula? Delta TF is equal to what we have to write? TF naught minus TF. This is the formula, students. Delta TF is equal to TF naught minus TF. TF naught are, students, what is the TF naught? TF naught is pure solvent. Correct? Freezing point of the pure solvent. Clear? Pure solvent. And TF is which one, students? Freezing point of the solution. Clear? Freezing point of the solution. Understood, Amma? Freezing point of the solution. Clear this one? So this is the third model, students, freezing point problem. And next we are going to discuss about the next problem, students. See here, 300 centimeter cube of aqueous solution of a protein. It contains 2.12 grams of the protein. The osmotic pressure of such a solution at 300 Kelvin is found to be this one. Calculate the molar mass of the protein. Now see, students, here is there any vapor pressure word? No. Boiling point word is there? No. Freezing point word is there? No. What is there? Osmotic pressure is there. Correct? Here osmotic pressure word is there. So that's it, is the fourth colligative property problem. So that's what is the formula, students? The osmotic pressure. What is the important formula? Important formula. Important formula, students. So what is the formula, students? Osmotic pressure given here. Osmotic pressure. What is the formula? M1 is equal to W1 RT by pi into V. Okay, na? So M1 is equal to what, students? Molar mass of the solute is equal to W1 RT by pi V. What is W1? Weight of the solute. R is the gas constant. T is the temperature. Pi is osmotic pressure. And V is the volume. Clear? So what students? W1 is equal to what? W1 is equal to weight of the solute. Weight of the solute. R is gas constant. Okay, gas constant. And next T is what, students? T is the temperature. Next pi is osmotic pressure. Osmotic pressure. And V is the volume. Clear this one? So this is the volume. Now see, students, here volume of the solution. Clear? Volume of the solution. Now see, Nana, here what given in the problem? 300 centimeter cube of an aqueous solution. This is volume given of a protein contains 2.12 grams of the protein. That means this is the weight of the protein, students. The osmotic pressure value given. So what is the formula, students, here? What is the formula we have to use? M1 is equal to W1 RT by pi into V. So M1 we have to find it. W1 is equal to how much given, students? Weight of the solute 2.12 grams given. R is the gas constant, in bracket value given 0.0823, and temperature 300 Kelvin given, 300 Kelvin. And next pi value, osmotic pressure is how much given, students? 3.89 into 10 power minus 3 given, and volume is equal to 300 centimeter cube given. That means 300 centimeter cube is nothing but milliliters given. We have to convert this into liters, students. That means we have to divide with 1000. Then how much you will get, Nana? 3 by 10, 0.3 liters. Okay, na? So these all values you have to substitute here. 2.12 into R value 0.0823 into temperature is 300 divided by pi value 3.89 into 10 power minus 3, and volume is equal to 0.3, students. So how to find it, Nana? So this one I am writing as 2.12 into 0.0823 into 300. It 10 power minus this one, it is in the denominator, it is going to numerator, it becomes 10 power 3. 3.89 into 0.3. Clear? So you have multiply, students, this everything. 2.12 2.12 into 0.0823, okay, into again 300 into 1000 into 1000 divided by 3.89 again divided by 0.3. Okay, 0.3. How much, students, answer? How much you got? 44,852.44. Correct? So 44,852.44 gram per mole. Understood, Nana? So this much we got answer. Understood, students, this one? So this is the osmotic pressure problem, students. You have to practice this formula. You have to remember M1 is equal to W1 RT by pi V. This is osmotic pressure problem, students. Okay, na? So in last video I uploaded first two colligative properties, students. That is relative lowering of vapor pressure, and second one is boiling point, elevation of boiling point problems I discussed. In this video I discussed freezing point, that is depression of freezing point, and one more problem is the osmotic pressure. Okay, na, students? Now I am giving the four problems, four formulas at a time, students. See here, you have to remember these four formulas. See here, first formula is vapor pressure. So important formulas. Important formulae. See, students, first one vapor pressure. First one is vapor pressure formula. Vapor pressure. So in vapor pressure, what is the formula, students? P naught minus P by P naught is equal to W1 by M1 into M2 by W2. Okay, and second formula is boiling point. Okay, now if boiling point word is there in the problem, so then immediately you have to remember formula. You have to write the formula boiling point, delta TB is equal to KB into W1 by M1 into 1000 by W2. Clear, students? This is completely belongs to solute. This is solvent. Clear? This is solvent weight. This is solute. Okay, now that means weight of the solute, molar mass of the solute. This is the molar mass of the solvent, weight of the solvent. So this is the completely belongs to solvent, students. Understood, Amma? And next, third formula, students. Third one is freezing point. What is the freezing point formula, students? Delta TF is equal to KF into W1 by M1 into 1000 by W2. Same formula, just in the place of B we are taking here F, freezing point. That much only, students. Okay, so this is belongs to completely solute. Correct? This is the solute and this one is solvent. W2 is solvent. Okay, now I am taking the fourth formula, osmotic pressure. What is the formula? Osmotic pressure. Osmotic pressure, M1 is equal to W1 RT by pi into V. Clear? M1 is equal to W1 RT by pi into V. So this is the formula, students. And here delta TB, if suppose delta TB value not given in the problem, they given two boiling points. One is pure solvent, another one is solution boiling point. Then how to find it? Delta TB is equal to, what is the formula, students? Delta TB is equal to TB minus TB naught. Clear? TB minus TB naught. This is the to calculate delta TB formula. And if suppose in the question delta TF value not given, so you have to find it. But if your pure solvent to solution freezing points given, then you can find delta TF. Correct? So what is the formula? Delta TF is equal to TF naught minus TF. This is TB minus TB naught. Solution minus solvent. This is solvent minus solution. Understood, students? Adhaitama. So like this. Okay, now these are the important formula, students. Colligative properties. These four formulas you have to remember, students. Then any problem from the colligative properties you can easily calculate, students. Here vapor pressure word is there, this formula. In the question boiling point word is there, this formula. Freezing point word is there, this formula. Osmotic pressure there means this formula you should use. And these are delta TB, delta TF formulas. Clear this one, students? I hope you like this video. Thank you very much, students. If you like this video, please like, share, comment and subscribe my channel, students. Please support me. Thank you, students.